Okay, so for our warm-up today, I need you to use your notes, your 2-2 notes, to look up the different forms of your quadratic equation. Oops. Can someone tell me what your vertex form is? Y equals what?
Mx plus b.
No vertex form of a quadratic, friends. What you got? Beautiful. Thank you, Rod. All right, it is a times x minus h squared plus k. Okay, where h and k are your vertex. Okay, we're going to use this today when we are given, the vertex and if we're given a point. Okay, the vertex we'll use to plug in for h and k. The point that they give us, we will use to plug in for x and y. Okay. The last form we talked about in 2-2 was intercept form. Does anyone have that in front of them that they can tell me? There we go. Beautiful. So I had our P's and Q's. Nothing was being squared because it's already in factored form. This is the only thing I didn't have the square going on. Okay. So we're going to use this when we're given, what do you think? Our x-intercepts and a point. So if we're given P0, Q0, I'll be able to use opposite P and opposite Q back into my formula. And then if we have a point, we can use that for x and y. And then the third form of a quadratic is standard form. And what does that look like? Y equals what?
X plus b.
That's a line.
Wait, what are you talking about?
For a quadratic, something being squared. What you got?
Ax squared plus bx plus c.
There you go. Ax squared plus bx plus c. So it has the three pieces. Okay? So what do all three of these forms have in common?
They start with an A.
They all start with an A, right? Am I ever going to be given the A value though? No. We will always have to find A first. Okay? If I'm given a vertex and a point, I can fill in all the pieces except for A. So I can solve for A. Okay? If I'm given intercepts and a point, again, I can replace all of my variables with a value except for A. So we will always solve for A first. Okay? Once you find your A, oh, this isn't, there we go. Okay, then you'll be able to replace A, H, and K. Those get replaced with numbers. Okay? And then intercept form will replace A, P, and Q with their values. Okay? We will always start with one of these, and then typically they ask us to write it in standard form. So we'll start here, and then we'll rewrite it probably by foiling or multiplying to get to standard form. All right? We're going to do one of each, and then we're going to do 2 word problems. Okay? If you have questions, please ask me, because I know it's a lot. Okay? So if you get lost or confused, tell me. Don't feel like you're out of place. I promise you're not. Let me know. Okay? If we don't finish today, we can always finish tomorrow before we get into your big idea stuff. All right? So that'll make sure we have clarity today and we're not rushing through it. All right, the first one we're going to start with, you're going to be given information in different ways, tables or graphs. So my first one is a table. It says it represents a quadratic and wants us to write the equation in standard form. But we can never jump to standard form. We always have to start with vertex or intercept first. Okay? With this one, what am I given in the table? Do I see x-intercepts or do you see a vertex? we see a vertex. Which one of these is going to be considered my vertex? Okay, yes, good. How do you know that that's your vertex? Awesome. On both sides, it becomes -5. So those are the mirror points, which means this was my middle, this was my vertex. Okay? That's how we can label my vertex. I also have to have a point to plug in. Well, I got 3 options. And it does not matter which one you use. Okay? Are you cool if I just use 1, -2 because it's first? Okay? That's literally the only reason why I'm picking it. Is because it was just first on my list. Okay? But you could have done 2 -5 or 4 -5. We would get the same A value regardless of what we use. All right, I have a vertex and I have a point. So we know we are going to be using vertex form. So y equals A times x minus h squared plus k. What am I going to use instead of y? What number? -2. Good, right? Because I've labeled -2 for my y. So we're going to have -2 equals, we don't know a, right? That should be the only letter left in here. All right, what is my x value that we're going to use? We're using a 1. What is my opposite h? Good, -3. And then what's our k value? -6. Good. Any questions about any of this setup? All right. From here, we're going to simplify and solve for our a. So we'll do parentheses first. All right. So what is 1 minus 3? -2, and then -2 squared gives me a positive 4. So this becomes -2 equals 4a minus 6. We're going to add that 6 over, right? -2 plus 6 gives me 4. So we have 4 equals 4a. So a has to equal 1. Good. So there's my 3 pieces, right, that we need to write it in vertex form. So now we can put it in vertex and then rewrite it, expand it and simplify it to look like standard form. Okay? You'll never be given an A or a B value. So we can never jump to standard. We have to start with one of the other ones first. Okay? Yes. Yes. All right, so I can replace A, H, and K with the values that we have. So we're going to have y equals an A value of 1 times x minus opposite h. So that's my -3 squared. And then our k is -6. The x and the y go back because it's representing any x and any y that's on the parabola. So that's why those stay x and y when we write the form. Good? Okay. Anything squared means it's being multiplied to itself. So that's x minus 3 times x minus 3. Order of operations tell me to deal with that exponent first, so that's what we're going to do. Okay? This is the foiling. So we're going to multiply first, outside, inside, and last. X times x is x squared. X times -3. -3 times x, and then -3 and -3 give me 9. Okay. From here, you would distribute your A value, and what's nice is it's 1, right? So that's not going to change anything. It's nice when that happens for us. But I can combine some light terms with my blues, right? Which 2 can I put together? Yeah, my 2 -3 x's, okay? So we're going to have x squared minus 6x plus 9. I still got that minus 6. Put those guys together and we get x squared minus 6x plus 3. There is my standard form. There is a way to check that you've done it right. You can graph the vertex form up here. You can graph this guy. Ooh, there we go. We can graph this one and our standard form on the calculator at the same time because they should be the same parabola. So if you graph them both and get two different parabolas, then you did something wrong because they should be the exact same thing. So there is a way to check your answer. All right. Any questions for me? Yes. Yes. All right, my next one, we're going to use a graph, okay? A graph can give you lots of information, okay? It can give you vertex, it can give you y-intercepts, it can give you x-intercepts, it can just give you a random point, okay? So it might be different each time. Make sure you actually look and see what has been given to you and what's been labeled, right? This graph, what's labeled for me? Right. My x-intercepts? Anything else labeled for me? Yeah, just a point. Good. Okay. So I have been given an x and a y, and I've been labeled my p and my q. So we're going to start with intercept form this time. Our intercept form from above tells me it's a times x minus p times x minus q. We ultimately need to replace a, p, and q with values. I currently have 2 out of the 3. We'll always have to find that a first. Okay, so to find a, we're going to plug in something for everything else. What are we going to plug in for y? 6. Good. So 6 equals, I don't know, times, what's my x value? Negative 4. Good. What's opposite p? Positive 6. Nice. We have x again. And then what's opposite q? Negative 2. Negative 4 plus 6 gives me what? 2. Negative 4 minus 2 gives me negative 6. 2 times negative 6. So I get 6 equals negative 12a. What's my last step? Divide. Divide both pieces by negative 12. 6 over negative 12 simplifies to negative 1/2. Okay? And we're going to keep fractions as fractions. Okay? If you really want to make it negative 0.5, you're not wrong. It'll be fine. Okay? I'm usually going to keep things as fractions if I can. Okay? Does it make sense that I have a negative a value? Yeah, my parabola is upside down. So we should have expected a negative a. Okay? If I would have gotten positive 1/2, I should have questioned. Like, oh wait, it should have been negative. I missed a sign somewhere. Okay? Alright, so we got my 3 pieces. There's my a, and here's my p and q. So now I can plug it in up here. Y is going to equal, my a is negative 1/2. Ooh, come back. Thank you. We're going to have x plus 6 and x minus 2. Sorry. So this is intercept form. So again, to check yourself, you could graph this in Desmos or graph in calculator. You already have the picture, so you should make sure it matches what you already have. Okay? It does say standard form, So we're going to have to multiply and combine like terms. When we multiply, I'm going to do my parentheses together first, and then I'll just distribute the 1/2 later. You can distribute 1/2 first. I will say the biggest mistake is people will distribute it to everything, and it doesn't. It would only get distributed just to x plus 6. Okay? So to avoid that mistake, do your parentheses first. Okay? Make it one parenthesis, because then you can just do 1/2 to all of it. So we're going to FOIL the x plus 6 and x minus 2. X times x is x squared. X times negative 2 is negative 2x. 6 and x is positive 6x. 6 and negative 2 is negative 12. Can I combine like terms? My two middles, yeah, negative 2 and 6 are going to give me a positive 4. Like that. And then our final step here will be to distribute your a value to each of those three pieces. So 1/2 times x squared is going to give me, oh, it should be negative 1/2, right? Negative, there we go. Will give me negative 1/2 x squared. All right, how about negative 1/2 times 4? What kind of a 2x? There you go, negative 2x. And then negative 1/2 times negative 12. Positive 6. Good. Awesome. And here's my standard form. And again, you could graph that. You already know what it should look like. You can make sure it does. Okay. So those are the two main ways, from vertex to standard, from intercept to standard. So you have an example of each. Okay? Whether you get information from a table or a graph, that could be different. But you'll either have a vertex or have intercepts. Got any questions for me before we go to the back and do our word problems? Okay, cool. Y'all feel okay? Okay, nice. I'm doing way better this time. All right, here we go. So example 3 is a performer is being shot out of a cannon, so we can visually see what that would look like. From a height of 15 feet, the performer reaches a maximum height of 35 feet after traveling 50 feet horizontally, and then lands on a net 90 feet from the cannon. Okay? The path of the performer can be modeled by a parabola, where y is the height in feet, that's labeled for you, and x is the horizontal distance in feet, that's also labeled for you. It wants to know what is the height of the net. Okay? So 90 is not an x-intercept. That wouldn't make sense, because that's going to be the ground. We're not going to land on the ground. That would hurt. Okay? So the net's going to be our safety net. It wants to know how high off the ground is the net going to be. Ready? All right. Let's label some stuff. We start 15 feet. Okay? So that's giving me a y-intercept. Okay? A y-intercept of 0, 15. There you go. Can y'all see that? Is that too far? We okay? All right, and then it reached a maximum height, that's a vertex, 35 feet after traveling 50 feet across. So 35, 50. 50 is actually the x. That looks like an 8. 50 is our x. 35 is our y for our height. We also know this is going to be our h and our k. So it told us it was the maximum, so we had been told that's the vertex. It's going to be a parabola, so we're going to curve up, reach the vertex, start to curve down. We're not sure where we're going, okay? The net is 90 feet away, and notice that's not on here. Okay, that's what we're trying to find. So I've been given a vertex, and then 0, 15 we're going to use as a point. So we'll use that for my x and y. So we're going to use what we did in example 1 to help us out. Now what's nice is it hasn't told me to put it in standard form, right? So we just need to find A to create a model, and we can keep it in vertex form, right? So let's do that first, and then we'll talk about how we're going to use 90 feet. Okay, so first off, vertex form. We always have to find A first because these three need to get replaced. Okay. What am I going to plug in for Y? 15. What gets plugged in for A? Nothing. Good job. You didn't fall for my trick. What gets plugged in for X? 0. What gets plugged in for opposite H? Negative 50. Good. We're going to square that. And then what is K? 35. Gorgeous. All right, parentheses, 0 minus 50 is negative 50, okay? And then I'm going to square that to get positive 2,500. Let's subtract our 35 to get negative 20 equals 2,500A. Divide both pieces by 2,500, and you're going to get negative 0.008 for your A value. Okay. Does it make sense to have a negative? Yes, we have an upside down parabola. Okay. If you want to convert that to a fraction, you can, but I bet you when you type negative 20 divided by 2,500, it's going to give it to you in decimal form. And when we're doing real life stuff, you can leave it like that. Okay. So do we have all three pieces? Yeah, we do. So let's complete our vertex form right here. So this is going to be negative 0.008 times x minus 50 squared plus 35. All right, so we have a function that models what's going on. I don't have to do any more. I don't have to rewrite this, okay? I can use this because the question is, what's the height of the net, okay? If I know the net is 90 feet away from the cannon, can I replace the x or the y with the 90? I can replace my x. Yeah, distance, horizontal distance. We're looking for an x of 90, right? So I'm going to take my red equation and make x 90. Negative 0.008 times 90 minus 50 squared plus 35. Right. We're not in Algebra 1 anymore. You don't have to show me step by step when it comes to solving. If you show me at least that, you're showing me where everything goes, and that's enough work to show me. You can type that in your calculator exactly the way you see it and give me the result. Okay? So I want to pull up. I turned off. There we go. Where you at? There it is. $90 minus 50 is what? 40. What's 40 squared? 1,600. You're good. So you would multiply 1,600 by negative 0.008 and then add 35. And if my calculator would come up, I would be so thankful. Or I could just use Desmos. Desmos would work too. Okay. Negative 0.008 times 90 minus 50 squared. And then what was it? Plus 35. So it doesn't have to give me a graph. You can just type things in like that, and you see how it gives me an answer in the corner. So we have an answer of 22.8. Okay. Okay. So if you wanted to show all your steps, you can. So 22.2, that is the height of our net. 22 feet is height of net. There we go. Okay, but you have to at least show me this before you plug it into your calculator, because that proves to me you know where to put things. We got one more. Oh, we got so much time.
Yeah, what are you gonna do after you finish this?
I don't know. Hang out, I guess. We could do more math.
Oh, no.
What's up?
I keep getting 47.8.
47.8?
Yeah.
Did you do negative 0.008? Do you have a
Oh,
negative?
that's a negative?
Yes.
Oh, I didn't see that.
Okay. Yep. Make sure your A is negative, because then that will probably fix it. Hurry. My next one has to do with temperature dropping. So my parabola is going to go the other way. Okay. So we don't have to create a graph. It's being given to us. We have a meteorologist creates a parabola to predict the temperatures tomorrow, where X is the number of hours after midnight, and Y is the temperature in degrees Celsius. So we have a graph. What is the graph giving me? What information are we getting? Beautiful. X-intercepts and a point. So I have an XY, and I have a P, and I have a Q. All right. It says write a function f that models the temperature over time. Did it say what kind of function? No. So do I have to make it standard? No. I can get my intercept form and stop. And then we're going to use it to figure out what is the coldest temperature. All right. Ready? So example 2 is going to help me with this one. So intercept form is y equals a, x minus p times x minus q. Our goal is to fill in the a, the p, and the q. We got 2 out of 3. We got to find my a. All right, what are we going to plug in for my y value? 9.6. What are you going to plug in for a? Nothing. Good job. What are you going to plug in for x? 0. What are we going to use for opposite p? Good. All right, I have x again, so 0 again. And then opposite q? Negative 24. All right. So that becomes negative 4 times negative 24, which is going to be 96a. So 9.6 equals 96a. Divide both pieces by that 96. And we're going to get 0.1 for my a value. My a is positive. Does that make sense? Are we opening up? Yes, so positive a works here. We have our 3 pieces, so let's write our model. So we're going to use y equals 0.1 times x minus 4 times x minus 24. So write a function. Okay, check. I did that. All right, so we have to use this now to answer the question, what's the coldest temperature? Okay, so coldest would be a minimum, right? As low as we go. And we now know that minimums are the same things as vertices. So we're trying to find our vertex, okay? The temperature is going to be the K value, right? So I'm trying to find my K. We always have to find H before we can find K, right? How do we find H when we had two intercepts? If you have two x-intercepts, how do you find the axis of symmetry? Yeah, it's in the middle. So you can add them up. 4 plus 24, cut that in half. That gives me 28 over 2, which is 14. And does that visually make sense? Does that look like it's about 14? Yes, that just proves it. Okay, you can't just look and guess. Okay, that proves that we have an H value of 14. I don't know, blah, blah, blah. I don't know the other part. But I can use my model to find that. Because isn't 14 technically an X value? Right? It's the first part of my coordinate point, right? Sorry, my pen is like running together. There we go. So let's plug 14 in for my X's. What's up? So we're trying to find this piece. So we're going to plug in 14 for my X. Like last time I plugged in 90. This time we're going to plug in 14. And our result is going to be the lowest temperature. So we're going to have y equals 0.1 times 14 minus 4 times 14 minus 24. Come on. Okay. 14 minus 4 gives me what, 10? 14 minus 24 is negative 10. And when you multiply all those together, what do you get? Negative 10. So our coldest temperature is negative 10 degrees Celsius. Yep.
The graph says.
I mean, does it though? How do you know that that's not negative 10.1 or negative 9.9, right? So we just got to be careful of looking at it. I know. Because like that looks like 14, but it could have also looked like 13. So that's why I verified it with adding and splitting it in half. So it is nice that it matches what we think it is. We just got to be careful. It doesn't ask me this, but what time is this happening? If it's 14 hours after midnight, what time of day is that? 2 p.m. Yeah, that's like a nice little bonus question. So at 2 p.m., we have the lowest temperature of negative 10 degrees Celsius. Yeah, I don't know where they are, but I would not be there. Where would you go where temperatures drop as the sun comes up?
Maine.
Where? Maine, Wisconsin?
Maine, Wisconsin, sometimes Colorado.
Okay. I'm not going to any of those places. Antarctica? Doesn't Alaska have like so many days of night? Like where the sun is gone? Maybe that's what's happening. Okay. Last little piece. So we're going to tie in a little bit of Algebra 1, and this also kind of leads you into something you might see in AP Pre-Calc next year. Okay? They love average rate of change. So we're going to talk about it often in this class. So when you see it next year, you're not going to be surprised. Okay? What is the average rate of change in temperature over the interval in which the temperature is decreasing and increasing? And then we're going to compare the two to see which one's faster. Okay? Do we drop temperatures faster, or do the temperatures go up faster? Okay? Average rate of change is really fancy for what? Other than S. And then slope. Slope, yes. All right? So we're just going to find the slope. Different color. Let's do purple. So we're going to find the slope from 0, 9.6 to the vertex of 14, negative 10. Okay, that's our decreasing. Do you remember your slope formula by any chance? Yeah. y2 minus 1 minus x2 over x1. So this is what we're going to use. All right, so we are decreasing first. We're starting at the point 0 and 9.6. And we're going to the vertex of 14, negative 10. So here's my x1, my y1, here's my x2, and my y2. We good?
Yep.
All right. All right, so we're going to have negative 10 minus 9.6 divided by 14 minus 0. This will give me negative 19.6 divided by 14. Someone check me. I think it's negative 1.2 or negative 1.4. Which one is it? Negative 1.4, thank you. Yeah. So we're decreasing at a rate. So we're losing about 1.4 degrees each hour, is what that's showing. Okay? I would like you to try the increasing. So increasing goes from 14, negative 10 to 24, 0. What you got? Who wants to help me just set it up first? All right, Harrison. Oh, do you have the answer?
I got both.
Okay, tell me how you set it up.
Put it 0 minus 10
Okay?
divided by 24 minus 14.
Okay.
I got negative 10 over 10.
Mm-hmm.
And that's
Negative 1. Awesome. Good. So, or it should be positive 1, right? Hold on, what happened? Oh, right here. See how this 10's already negative? Because we're increasing, right? That's how I knew something. We got a sign mixed up somewhere. Right here, it should be 0 minus negative 10, which really becomes what? Plus 10. Boop. Come on. Erase. Thank you. All right, so now I can compare. I have a decreasing rate of negative 1.4. I have an increasing rate of 1. So if I compare the two, which one happens quicker? Our decrease. Okay? So we're dropping 1.4 degrees each hour. Okay? But it raises only 1 degree per hour. So we're dropping faster. So decrease rate is faster. Laura, I'm not ignoring you. Yes. What was your question?
In the top said the
Should the what? Should the top set be the other way around? Hmm? Zero minus negative 10. If you, honestly, if you did negative 10 minus 0, that's fine as long as what's under is 14 minus 24. So yeah, you can do it the other way, you'll get the same thing. Yep, as long as your 14 and negative 10 are stacked on each other, and your 24 and 0 are stacked on top of each other. Okay? Any questions for me? All right, good job.